To understand why it's so hard to find planets orbiting distant stars, you have to get a sense of just how far those stars are from us here on Earth.
Now, if I were to build a scale model of our galaxy, the Milky Way, starting here in the solar system with this of the Sun, then let's say I put the Earth 1 centimetre away. So actually, if the Earth were that big, then the Sun would be as big as this tea shop, but ignore that for a minute. Let's say this is the Sun, and let's say I place the Earth 1 centimetre away. Now that's known as 1 astronomical unit. So if I go to the outer planet of the solar system, Neptune, that's about 30 astronomical units, so 30 times further away. Then onwards to the edge of the solar system, there's the ex-planet Pluto. And Pluto sits around 50 astronomical units away. So we've got about 50 centimetres representing the size of our solar system out to Pluto. Now, on here somewhere, on a mountain on the Earth in Hawaii, there's one of Earth's most powerful telescopes, the Keck telescope. And it took a picture of Pluto and its moon, Charon. And this is the best you can do with one of the most powerful telescopes we have. You can see that it's a disk, but it's a pretty featureless blob.
At its furthest point from the Sun, Pluto is about 50 astronomical units away. But that's nothing when you're building a model of the Milky Way. Because the nearest star to our Sun is 268,000 astronomical units away. It's a star called Proxima Centauri. And to mark its position in my scale model, I have to get much further out. If the Earth is 1 centimetre from the Sun back there in the tea shop, then Proxima Centauri would be here, 2.5 kilometres away. And that's just our nearest star.
Now, the Keck telescope doesn't have any trouble seeing Proxima Centauri, of course, because although it's 4 light years away, it's 100 times the diameter of Pluto, and it's a star. It's a giant nuclear fusion reactor giving out light. But imagine trying to see a planet in orbit around Proxima Centauri. They're much smaller than the star. They don't give out light, of course, they only reflect it, and they get lost in the glare of the star. So trying to see a planet around Proxima Centauri would be equivalent to trying to see a grain of sand 100 miles away in the glare of a spotlight.
Planets orbiting distant stars are so far away and so difficult to detect that we discovered one for the first time just 20 years ago. Far too distant to be seen by any telescope on Earth, it was found by scientists who weren't looking for planets at all. They were looking for pulsars.
Pulsars are neutron stars, the remains of dead stars, the leftovers of supernova explosions, and they're incredibly small and dense. They can be the size of a city, but be more massive than the Sun, and they can spin very fast on their axis. And when they do that, you get beams of intense radiation that's spinning around, sort of like a lighthouse beam, and that lighthouse beam can cross the face of the Earth. And so we see a series of bright, regular pulses, and that's what gives them their name.
The timing of the pulses is so precise that they are as accurate and reliable as an atomic clock. But in 1992, scientists noticed something strange. One of the pulses missed a beat. It was as if the pulsar had wobbled.
Now, our Sun also wobbles as it spins on its axis, and that's because it's surrounded by planets. See, the gravitational pull of the Sun keeps the planets in orbit, but planets are also massive objects, and so they exert a gravitational pull on the Sun, and that causes it to wobble slightly. So those scientists back in 1992 realised that they were seeing the same thing happening to the pulsar. Those precise rhythmic beams were being knocked out of sync slightly by the gravitational pull of a planet.
The discovery proved that there is a way to find planets that are too distant to be seen. They can be detected because they cause the stars they orbit around to wobble. And just 3 years after the first planet was discovered, another wobble was detected in a star in the constellation Pegasus. And this star wasn't dead like the pulsar. It was a star like our Sun. It was the unmistakable sign of a planet. They named it 51 Peg B. The discovery of 51 Peg B was a real watershed moment because it's the first time that we found a planet orbiting a living star beyond our solar system. Now today we found over 700 planets, which is fascinating in itself. But for me, the most interesting thing is that it takes us closer to a far more precious goal, which is to discover an Earth-like planet around a distant star, a planet that maybe could harbour life.